Hello students. So in the previous video, we had discussed the important basics of trigonometry. So let's solve problems based on it in this video. So the first question, in triangle ABC, right angled at B. So what they have given us is a right angle triangle. So let's draw a right angle triangle. Okay, let me make use of the straight lines itself. Initially, this chapter seems to be a bit difficult, but later on, trust me, this will be the easiest chapter. Okay. Most of the students have felt this is the easiest chapter. Let's take a right angle triangle ABC. Okay. A, B, C. Okay. Now, right angle at B. Okay. Now, AB equals 24 centimeter. Okay. AB value is given as 24 centimeter. And BC value is given as 7 centimeter. Okay. What we have to do is we have to find in the first sub question, we have to find sine A cos A, which means see sine A, it represents, see usually we write sine theta, isn't it? So instead of theta, we have got capital A here, which means the angle under consideration is at A. So this is the angle under consideration. Now, which becomes the opposite side? BC becomes the opposite side. Now, opposite to 90 degree becomes the hypotenuse, and the remaining left out will become the adjacent side. Okay. Now, what is sine A? Sine A or sine theta is basically the ratio of opposite by hypotenuse, isn't it? We wrote sine theta as opposite by hypotenuse. Now, instead of theta, we have got A here. That's it. Sine is basically opposite by hypotenuse. Remember that. So here the opposite is BC and hypotenuse is AC. But we don't know the value of AC, isn't it? So we have to find the value of AC. So throughout in this chapter, any two sides will be given. The third side won't be given. We have to find the third side using the Pythagoras theorem. That's what we are going to do now. Okay. So let's take in triangle ABC, angle B is 90 degree. Therefore, using Pythagoras theorem, we get AC squared as AB square plus BC square, isn't it? The square of the hypotenuse is equal to sum of squares of other two sides. Now, what is AC? We have to find it. What is AB? 24 square and BC is 7 square. So AC square is equal to 24 square is 576 and 7 square is 49. Therefore, we get AC square is equal to 576 plus 49 is 625. Therefore, AC is equal to square root of 625. Square root of 625 comes out to be 25. Therefore, AC is equal to 25 centimeters. So we got the value of AC. So let's find the value of sine A and everything. So sine A is basically opposite by hypotenuse. Here opposite is BC and hypotenuse is AC. So we know the value of BC is 7 and the value of AC is 25. Therefore, sine A will become 7 by 25. Similarly, let's find, before that, let's make some space. Okay. So now, okay, let's find cos A. Basically, cos is adjacent by hypotenuse. Here adjacent is AB. AB value is 24 and AC value is 25. Therefore, cos A will become 24 by 25. This was our first sub question. So in the second sub question, what we have to do is we have to find sine C now. Okay. Now the angle, let me scroll it a bit. Yeah. Now the angle is not at A, instead the angle is at C now. Okay. So the opposite side, now the opposite side is AB, adjacent side becomes BC. Okay, that's it. So sine C. What does sine C? Sine is always opposite by hypotenuse. So opposite here is AB. Let me write the formula. Opposite by hypotenuse. Here now the opposite is AB and the hypotenuse is AC. So AB value is how much? 24 and AC value is 25. Okay. Let's find cos C. Cos is adjacent by hypotenuse always. Now which is the opposite? Sorry, which is the adjacent? BC, and which is the hypotenuse? AC. So 7 by 25. Remember, if you change the angle, earlier it was A, now it is at C. Only the opposite and adjacent swap, they exchange. Okay, but the hypotenuse remains the same. I'm sorry. Let's get into the second question. Before that, let me recall what we have done. So it's very easy. What we have done here is two sides of the triangle were given. We found the third side using the Pythagoras theorem. Once we know all the sides, we can easily find whichever ratio they've asked for. So here they've asked for sine. So sine is basically opposite by hypotenuse. So sine A. So if the angle is at A, opposite is BC. So therefore BC by AC will be the answer. So BC value is 7 and AC value is 25. So similarly, we found cos A. Now if it is sine C, now the angle is at C, therefore the opposite side becomes AB and the hypotenuse is AC itself. So AB by AC is the sine C value. So which is 24 by 25. So let's get into the next question. So in the next question, if you observe the next question, in the figure, find tan P minus cot R. Okay, we have to find tan P minus cot R. Remember again, the two sides of the triangle is given, PQ and PR, but QR is not known. So we have to find QR using the Pythagoras theorem. So let's do that. Okay. So in triangle PQR, as you know, angle Q is 90 degree. Therefore, using Pythagoras theorem, we get PR square is equal to PQ square plus QR square. So PR is 13. 13 square is equal to PQ is 12 square. QR we have to find it. Okay, 13 square is 169. 12 square is 144 plus QR square. So 169 as it is, get the 144 to the other side. That will be equal to QR square. 169 minus 144 is 25. So 25 is equal to QR square. Therefore, QR will become, actually we have to take plus or minus, but since it is a length of the triangle, we take only the positive. Length of a triangle cannot be negative, right? So we directly take square root of 25. What is square root of 25? 5. So therefore, QR value is 5 centimeters. Okay. So we'll also write it down here. QR value is 5 centimeters. Now, we have to find tan P minus cot R. First, let's find the value of tan P. See, what is tan? Tan is opposite by adjacent. That's the formula, right? Now, tan P, meaning the angle is at P. If the angle is at P, which is the opposite? QR is the opposite. Which is the adjacent? PQ will be the adjacent because this will be the hypotenuse always. So if P is the angle, the opposite side is QR and the remaining will be the adjacent. So QR is 5, PQ is 12. The next thing that we have to find is cot R. What is cot definition? Adjacent by opposite. Now, cot R, remember it is not cot P. Okay, it is cot R. Now, the angle is at R. If the angle is at R, the opposite side is PQ. The opposite side is PQ. This becomes the opposite side. If this is the opposite side, which is the adjacent? QR is the adjacent. So, it becomes QR by opposite is PQ. Okay. Now, QR is also 5, PQ is 12. So, therefore, tan P minus cot R. Tan P is 5 by 12. minus cot r is also 5 by 12. Plus 5 by 12 minus 5 by 12 gets cancelled. So we'll be left with the final answer, that is 0. That will be the final answer. Remember, if it is tan P, so let me use a different color to indicate it. Here, tan P, which means the angle is here. So this is the opposite side, and this becomes the adjacent side, and this is the hypotenuse. So tan is what? Opposite by adjacent. So it becomes QR by PQ. That's what we have written in the first case. In the next case, it is tan cot R. So the angle is at R. So if the angle is at R, the opposite side becomes PQ, adjacent side becomes QR. So what is cot? Cot is adjacent by opposite. So it will become QR by PQ. So again, QR by PQ is 5 by 12. So if you subtracted 5 by 12 minus 5 by 12, we get the answer as 0. Okay, let's get into the next question. A very, very important question. Okay. Now listen. If sine A is equal to 3 by 4, they have given the value of sine. Okay. We have to find the value of cos A and tan A. Okay. Let's do it. First, what we'll do is we'll take a right angle triangle. Let me take this triangle itself. Okay. Let me take this triangle. Okay. So I've taken the right angle triangle. Okay, A, B, C. Okay. This is the right angle triangle. Now, as you can see, they've given sine A, which means the angle is at A. So the angle is at A. So BC will become the opposite side. Opposite to 90 degree will become our hypotenuse, and the remaining one will become the adjacent. Okay. Now, what is given? It is given that sine A is 3 by 4. Now, what is sine? Sine is defined as opposite by hypotenuse, isn't it? Sine is defined as opposite by hypotenuse. According to the figure, what is opposite? Opposite is BC and hypotenuse is AC. Now, from the question, sine A is given as what? 3 by 4. Now, from this step, we can conclude that BC will be equal to 3 and AC will be equal to 4. Remember, we are not supposed to do like this. See, if two things are in ratios like this, you cannot take numerator is equal to numerator, denominator is equal to denominator. That is wrong, completely wrong. But here in trigonometry, we can do that because at last what we are trying to find is a ratio. Cos A and tan A are what? They are also trigonometric ratios. Okay, so we can directly take BC as 3 and AC as 4. But that is not the correct way. First, let's understand what are ratios. Basically, ratios are comparing quantities. Okay, suppose let's say A and B are two persons. Okay, suppose A is having 2 chocolates and B is having 4 chocolates. You can easily say that B is having double the chocolate of A, isn't it? He's having double the chocolate of A. Now in ratio, what we do is we just divide it 2 by 4 and we write it as 1 by 2. So we say it as 1 is to 2. Meaning 1 is to 2 means if a person has got 1 chocolate, the other person is having double of it, 2 chocolates. So suppose if a person is having 4 chocolates, double of them in the sense 8 chocolates. So 1 is to 2 means, see, I'm sorry, I cannot write now A, see, 2 by 4 is equal to 1 by 2. That's what we have got. Can I tell A is equal to 1 and B is equal to 2? Is that the actual value? No. The actual value of A was 2 and the actual value of B is 4. Okay. But when we take ratio, we always reduce it to the simplest form. I'll give you one more easier example. Let's say A is 20 and B is 25. So if you take the ratio A by B, it becomes 20 by 25, which is 4 by 5. 5 fours are 5 fives are. Therefore, you get the ratio as 4 by 5. Now, can I say A is equal to 4 and B is equal to 5? No, that's wrong. Because the actual value of A is 20 and the actual value of B is 25. So whenever you take a ratio, you express it in the simplest form. Okay. So to get back the original, usually what we do is, if you remember in geometry, when you were finding the angles, If suppose two angles are given in the ratio 2:4, you will take, let the angles be 2x comma 4x. Do you remember that? Now, why do we multiply x here? Because if you observe here, see, you have reduced it to the simplest form, meaning there was a common factor between 20 and 25. Which was it? In other words, which is the number that divides both 20 and 25? It is 5. So you just eliminated that. Okay, to get back it, see here you have divided it. To get back, what should you do? You should multiply it. If you multiply, you get back your original one, isn't it? So you multiply the common factor. Similarly, when the angles are given in the ratio 2:3, why do you take 2x and 3x? Is because, see, there might be some common factor which was eliminated. Okay, to get back, what should we do? We have to multiply. We don't know what is the common factor that is eliminated, so we take it as x. So that's why we take it as 2x and 3x. 2 into x, 3 into x. Okay, so here also, if BC by AC is equal to 3 by 4, remember, we cannot say BC is equal to 3 and AC is equal to 4. That is wrong, completely wrong. Okay, now BC is 3 times some x. There is some common factor. See, always ratios are expressed in simplest term. So there must be some common factor which is eliminated. To get back the original, what do? We have to multiply the common factor. You can take x, or sometimes you can also take k. So you have to take it as 3k and 4k, the actual procedure. But in trigonometry, you need not take it as 3k and 4k. You can directly take it as 3 and 4, because at the end, what you are trying to find is a ratio itself. Again, the k will get eliminated in the end also. So it's very convenient to directly take BC as 3 and AC as 4. Remember, this is applicable only for trigonometry here. Okay, but in another place somewhere, suppose you come across a question like this: x by y is equal to 1 by 2. Remember, you cannot take x as 1 and y as 2. That is completely wrong. X should be equal to 1 times some k and y should be equal to 2 times some k. This is the actual procedure. So with that note, I hope you guys have understood. Here, I can directly take the value of BC as 3 and the value of AC as 4. Anywhere else, you are not supposed to do like that. Okay. Now, so we got to know the value of BC is 3 centimeter or whatever units, and AC is 4. Okay. Let's find AB using the Pythagoras theorem. So in triangle ABC, angle B is 90 degrees. So using Pythagoras theorem, we get AC square is equal to AB square plus BC square. AC is 4. So 4 square is equal to AB. We have to find it. BC is 3 square. So 4 square is 16 is equal to AB square. 3 square is 9. Get 9 to the other side. 16 minus 9 is equal to AB square. Therefore, AB square is equal to 16 minus 9 is 7, which implies AB is equal to root 7. So we got the value of all the three sides. Okay. Now, let's find the ratio. Okay. So what we have to find is cos A. Cos is what? Adjacent by hypotenuse. So what is our adjacent here? Our adjacent here is AB. Hypotenuse is AC. So AB value is how much? Root 7. And AC value is 4. So it will be root 7 by 4. So similarly, let's find tan A. Tan is what? Opposite by adjacent. Opposite is BC. Adjacent is AB. So BC value is 3. Adjacent value is root 7. So it will become 3 by root 7. So remember, they had given us sine value, which is 3 by 4. And we know that sine is opposite by hypotenuse. From the figure, opposite is BC, hypotenuse is AC. From this thing, we got to know that BC is 3 and AC is 4. When we get two sides of the triangle, right angle triangle, we can find the third using the Pythagoras theorem. That's what we have done. Once we know all the three sides of the triangle, you can easily find any ratios that you wish for. So we need cos, which is adjacent by hypotenuse. From the figure, adjacent value is root 7, hypotenuse value is 4. And we need tan A value. Tan is opposite by adjacent. Opposite is 3 and adjacent is root 7. 3 by root 7. So this is what we have done. Remember, I'm stressing a lot on this. You're not supposed to take anywhere else. Suppose if you've got x by y as 3 by 4, you cannot say x is 3 and y is 4. That is completely wrong. But here you can do that because Anyhow, at the end, what are we doing? We are finding a ratio itself, isn't it? We are finding a ratio itself. Again, that common factor gets cancelled here also. Okay. So that is why directly we take BC as 3 and AC as 4. Okay, students, in the next video, we'll continue with the next problem. Thank you.